Hi, here is a question in the topic quadratic equations. Given that the roots of the equation px squared plus qx plus 1 equals 0 differ by 2, show that q squared is equal to 4p squared into p plus 1. Alright, so the quadratic equation given is p, the quadratic equation given is px squared plus qx plus 1 equals 0. Alright? Now, this is a quadratic equation in terms of x. Okay, p and q are real constants, so the only variable here is x. So it's a quadratic equation in terms of x. And we are told that the roots of this quadratic equation differ by 2. All right, so since we don't know the roots, let us call the first one. All right, let us call the first root to be alpha. All right, for them to differ by 2, the second root will be alpha plus 2. So that this minus that will give us 2. The roots differ by 2. Now, we are going to use the knowledge of the relationship between the coefficients of a quadratic equation and its roots. Now, let's just look at the standard quadratic equation. It's ax squared plus bx plus c equals 0. All right? For this standard equation, we know that sum of roots, we just call it for short SR, sum of root is always negative b all over a. All right, product of roots, we call it for short PR, is a all over c. All right, if we compare this and that, we will see that our a is p, our b is q, and our c is 1. Okay, so let's find out now, what do we have as sum of roots? Sum of roots means we add up the roots. The roots are alpha and alpha plus 2. So alpha plus 2. The sum of roots is minus b all over a. Our b is q. So it's minus q all over a. Our a is p. Product of roots. That means we take this product, this root multiplied to this root. Alpha multiplied to alpha plus 2. Product of root is a all over c. Our a is p and our c is 1. That simply gives us p. Okay, we have these expressions here. We are told to show that, let's write what we want to get. We want to show that q squared is equal to 4p squared into p plus 1. This is what we want to show. Given this information, can we derive this expression? That's the challenge here. What do we do therefore to get this expression? If you look at the expression, there's no alpha in the expression. So it makes sense if we solve for alpha, all right, in these two situations, these two information that we have here. All right, let's first of all simplify them as equations. If we take the first one, we're going to have alpha plus alpha is 2 alpha plus 2 is equal to negative q all over p. So the first situation, we're going to have 2 alpha plus 2 is equal to negative q all over p. We can call that equation 1. In the second scenario, we have alpha squared plus 2 alpha is equal to p. Alpha squared, that's why we multiply out this, alpha squared plus 2 alpha is equal to p. We call that equation 2. Given these two equations, let's solve for alpha. We see we can easily solve for alpha using equation 1. Okay, so using equation 1, all right, equation 1 is 2 alpha plus 2 is equal to negative q all over p. We take this positive 2 that way. We're going to have 2 alpha is equal to negative q all over p minus 2. To get alpha, we'll divide both sides by 2. We'll divide here by 2. Divide here by 2, we'll have alpha, all right, into, dividing by 2 simply means taking a half. All right. All right, this gives us negative negative cure all over 2p minus 1. All right, so that's the expression for alpha. We got the expression for alpha. All right, now let's take this expression for alpha. Since we earlier used equation 1, we'll now have to put it back in equation 2. That's the substitution method for solving simultaneous equations. We can't go back to equation 1. We now have to put this expression for alpha in equation 2. So putting in equation 2, what do we obtain? Putting in equation 2, what do we obtain? This is the equation 2. So we have alpha squared. So we're going to get negative cure all over 2p minus 1 squared for alpha squared plus 2 alpha. 2 negative cure all over 2p minus 1 is equal to p. All right, so you see, finally, we don't have any alpha anymore. Our expression we want to derive again is cure squared. Let's write it somewhere. Cure squared is equal to 4p squared into p plus 1. This is our expression we want to derive. So we have to derive this from here. All that we'll be working here is to make sure that we get this. All right, so let's open this parenthesis. We square this expression. Remember this expression? It is negative cure all over 2p minus 1 into itself. Negative cure all over 2p minus 1. Okay? All right. This multiplied by itself. Negative multiplied to negative is positive. Cure multiplied to cure is cure squared. 2p multiplied to 2p is 4p squared. All right. This negative cure all over 2p multiplied to negative 1 become positive cure all over 2p. All right. This again, negative 1 multiplied to that is positive cure all over 2p. Negative 1 multiplied to negative 1 is plus 1. Okay. Now, cure all over 2p plus cure all over 2p. All right, the LCM is just 2p. 2p divided by 2p is 1, multiplied to cure is cure. 2p divided by 2p is 1, multiplied to cure is cure. So this gives us 2 cure all over 2p, which is cure all over p. All right, so this here gives us cure all over p. So let's continue here. So this expression now becomes cure squared all over 4p squared. In the place of this, we write plus cure all over p. All right, open out this. This 2 multiplied to this 2 will cancel this 2. We're left with negative cure all over p. Negative cure all over p. 2 multiplied to negative 1 is negative 2. Is equal to p. All right, we see this expression here. Cure all over p minus cure all over p is 0. All right, so we're left with cure squared all over 4p squared minus 2 is equal to p. Okay, so what next do we do? Pay attention, we left out something here. There was a plus 1, so we're supposed to have cure squared all over 4p squared plus 1. Plus 1. It was supposed to be plus 1. We got this one. We did not get this one correct. We forgot this plus 1. Cure squared all over 4p squared plus cure all over p plus 1 minus cure all over p minus 2 is equal to p. So that this and this gives us 0. So we have cure squared all over 4p squared minus 1 plus 2 gives us minus 1 is equal to p. As plus 1 minus 2 is minus 1. 1 minus 2 is minus 1. So again, our eyes are here. What do we need to do? See, we have cure squared on the left hand side. So it makes sense if we take this plus 1 that way, this negative 1 that way. So we have cure squared all over 4p squared is equal to p plus 1. This negative 1 go over there, become positive 1. So we are looking here, we need to have q squared alone. So all we need to do is to multiply both sides by 4p squared. All right, if we multiply here by 4p squared and also multiply here by 4p squared, okay, we see 4p squared cancel 4p squared, giving us q squared is equal to 4p squared into p plus 1. So do we get the expression that we are required? Yes. So we have arrived at this expression. Thank you.